At a local high school here in Mountain View, California, we found a group of enthusiastic students who design and build robots. As well as winning prizes for their inventions, they also learn the art of communication and teamwork. Learning whilst having fun is definitely the best way to learn. I'm Val Jeffrey for The Better Part. Stay tuned. We'll be right back. Building a robot is quite complex and includes skills such as creativity, engineering, and teamwork. How do robotic creations evolve? Our guests from the Mountain View High School Spartan Robotics team 971 from California are winners of FIRST, short for Inspiration and Recognition of Science and Technology. Students work with mentors and team alumni to design, prototype and produce a robot to compete in the game. Today we have 3 members of the 2018 team. Please introduce yourself, starting with you, Bahar.
Hi, I'm Bahar and I've been on the team for 3 years now.
My name's James. I've been on the team for 2 years.
My name's Sabina and I've been on the team around 5 years. And this is Curiosity, who's been on the team for just a year.
How did Spartan Robotics FRC Team 971 get started?
So the team was founded in 2002 by a group of students that really wanted to pursue robotics, and since then it's changed hands with some teachers helping, and now we have a really great group of mentors that keep the team running as the students change every year.
When a competition gets announced, how long do you have from being given the task to completing a robot?
So officially, from the reveal of the competition to bag day, where we have to seal up the robot and stop working, we get 6 weeks.
How is the team leader selected, and how do you put the drive team together?
So I was the team captain, the team leader for the 2018 season, and our mentors create a first draft of a leadership positions based on team interest, and I was definitely interested in being part of leadership, and that ended up happening, which was really exciting. And the team as a whole, the Student Leadership Council votes on the slate of leadership. So it's a joint effort between the mentors and the students. And then Drive Team is a little different of a process. We have drive practices where all team members are invited to come and practice driving the robots. And then from there, there's a series of selection processes where different team members get to try things out, and eventually you get to see who's the best fit.
What are the drive team assignments?
The drive team assignments are driver, manipulator, a human player, and coach. So we have a really great mentor who coaches the drive team once they get selected. Driver is anything that makes the robot move on the ground. So it's, because it's called the drivetrain, it's the driver. And then the manipulator does everything that the objectives could be. So it moves the arm on this robot or the intakes. And then the human player deals with other aspects of the game. So we can either help the coach if they need an extra hand, or in this game there's power-ups or pretty much anything on the field that the people can touch.
In the actual competition, what does the human player do? I believe you were the human player.
I was the human player this year, yeah. So in the game there's these things called power-ups. So if you score the cubes on your side of the field, you can push them through a slot in the driver station so that humans can touch it without getting hit by any robots. And you put them in slots, so a lot of that is just picking them up and placing them in, and then strategically activating each power-up so that we can get as many points as possible.
What tasks did you have to accomplish for the game?
So the main task that we were trying to accomplish was the placement of the cubes. And so, as I said before, there are shorter objectives, which are quite easier, only 2 feet off the ground, versus the scale, which is the large thing in the middle. We had to figure out how to bring cubes up at its maximum 8 feet in the air without having a tippy robot and being able to place them strategically to get the most on our side.
So don't other robots get in your way?
They do occasionally. So the way the way the game works is there are teams of 3 playing against each other, and each one of those teams of 3 is called an alliance. So you're working with your alliance members, so hopefully they're not getting in your way. But oftentimes other teams will try to play defense, and that's where the drivetrain comes in handy, because if you build something powerful enough, you just push right through.
Well, you have to do it quickly, that's for sure, but you also have to be accurate. So what's the most important? How do you weigh one against the other?
I think that accuracy is the most important, and once you have accuracy at a dependable level, you'll be able to integrate speed into that, and it'll just come naturally. For this game especially, because you're stacking boxes on top of each other, if you're just trying to go as fast as possible and you're throwing up boxes with no care, things are going to fall down, and it's just not going to be the return you want, where if you're more accurate, you'll gain speed from that.
And that's why we have drive practices, is to build that accuracy, and then at the competition, hopefully, we're at the point where we're fast as well.
Right. You must spend a lot of time putting these robots together. How much time do you have to dedicate to complete your robot?
It really, the way we approach this is you get out of robotics what you put into it. So though there's complete variance, the most committed members will be typically spending 40 plus hours a week. We meet typically for the entirety of the weekend and a couple of nights during the school week, though really it could be anywhere from 2 hours to 40 plus.
How many did you put in, do you know?
I was probably on the more 40 hours a week side of things. I tended to stay very late machining parts.
It's like having a full-time job that you don't get paid for.
Yes.
Get paid
Rewarding,
for in
though.
learning. Yeah,
Yes,
exactly.
yes. How many people were there on the 2018 team, and what was the camaraderie like?
I think there was around like 40 kids, and then around like 20, 15, 20 active members, I think. And I think the camaraderie was, I really liked it. We all kind of bond because we're all stuck in a room together doing one thing that we all share. So I think that the camaraderie at some point, you start a little bit rocky at the beginning, but we all become like a big family at the end.
You're all getting older every year, so next year, are you going to have to change your team because people are leaving, or how does that work?
As team members leave and become alumni, obviously we have the issue it's a complete turnaround every year. As you know, I'm the graduating senior. I'm never going to be a student with these two ever again.
Oh.
But that doesn't mean that I'm done with the team. We have a really great alumni network. We get together for potlucks and meetings. And in fact, typically, ex-team members, especially once they come back to this area, wind up as mentors. And we stay with first, though maybe not with the team we started.
Good. So you'll be there next year helping them anyway, putting in another 40 hours.
Possibly, yeah.
Jerry and I came and watched you in San Jose, and you did a wonderful job. You really did.
Thank you.
And the teamwork was extraordinary.
Yeah.
Now, all this starts with a kickoff meeting, so what gets covered then?
It does. So FIRST, which is the organization that releases the game, releases it around 7:30 in the morning. So unfortunately, due to teenagers, it's really rough, but we all show up there at 7:30 in the morning. We sit in chairs and we watch the game get revealed. So it's normally an animation, and it'll walk you through the basics of the game. And then after that, we'll discuss kind of ideas, and they release a game manual. So the game manual has points, it has fouls, everything you could ever do to just immediately start trying to think about what the robot can do and what it will do. We split into groups, and we talk about all the different things that we want our robot to do, and then how we're going to achieve that, what mechanisms we need. And then from there, we just kind of blast off, and we probably work on that for around 2 or 3 days before we start really prototyping and getting into it.
How do you build the prototype?
We have this thing called 80/20. So pretty much there's 2 different kinds of prototyping. There is the computer-aided design portion of it, which we call Crayola CAD. And that's basic geometry, basic shapes, trying to make sure things are feasible, especially a double jointed arm. That's kind of hard to make in real life and then hope it works. So that's something where you kind of have to do the math on it. But other things, like the intakes, we prototyped in real life. So we cut out sheet metal and just kind of put some bearings in it and tried to map things out in the real world so that we can talk to CAD and get things solidified that way.
You make it sound so easy.
Yeah, it sounds easy. I just wish it was that easy.
What kind of materials lend themselves to making the robot?
So go ahead.
So the robot, the majority of it we make out of aluminum. It's easy to work with metal, strong but light. However, oftentimes that's not enough. In fact, this robot's quite unique because we used a fair amount of carbon fibre. In fact, the black parts of the arm are all carbon fibre tube because basically aluminum would have weighed entirely too much for that application. We have also make use of plastics such as Delrin, and in fact a large part of our robot this year was 3D printed out of a material known as onyx. Really, we'll use anything available, but the majority of the work is done in aluminum and plastic.
Yeah. And we're able to cut aluminum and plastic in our shop too, so it really lends itself to our designs.
Yeah.
It's smart using the carbon fibre because that's lighter as well. You put it on a diet.
Yeah.
Yes.
There is a weight limit on the robot, so
Yes.
that's one of the challenges that you have to overcome.
I will confess, at Champs we were, I think, 0.2 pounds under the weight limit.
Oh, well done.
And that's on top of, if you look at our drivetrain, there's actually a wheel that someone spent the time and drilled holes into the wheel in the plastic part of it because we were just overweight. So I think the night before Champs, we just started drilling. And
Very creative, very creative. Do you build more than one prototype? And what are some of the reasons you might discard or eliminate a prototype?
So typically a mechanism will go through, especially if we're prototyping it in the real world, it will go through multiple iterations. This can start from the most basic, let's just see what happens if we put a motor here, here and here, to more, as we work out the geometry and what works, we'll think. For example, the intakes this year, we went through 3 or 4 different prototypes.
Complete prototypes too.
Yes.
Okay. Yeah.
But whereas other mechanisms like the claw, though we were working on 2 different ideas for how to do that, we only went through 1 or 2 prototypes of each before we settled on one that worked.
What was the defining feature of the 2018 robot?
I think it's different for every single person, but for me, because I spent a lot of my time on code, I think that the arm is really great and the intakes are really great, but I favor the arm just because it's so complicated and you can actually watch the robot if you push on it when it's enabled, which is really dangerous. But if you do it, it'll fight against you. So for me, I think the code was the defining moment because it makes sure everything runs, keeps everything together. But I'm extremely biased.
Yes.
And part of the reason I think a lot of our team members see the arm as the defining part of the robot is because we're one of the only teams that had this sort of design. There are a lot of teams that did different kinds of elevators, maybe a single jointed arm, but I think we were the only team that had a double jointed arm of this magnitude.
The team got a design award too. What was that for? Was it the arm?
Yeah, well, it's called the Industrial Design Award, and I think definitely a lot of that was because of our presentation of the arm. It does look very industrial as well, as you can see, and that award just kind of celebrates teams that have efficiency in design with some industrial aspects. So definitely with the arm, all the machining we do for our parts, that's very in the style of the industry.
It also helps that we implemented a few new technologies to FIRST in general this year. Things like our arm is run off a cable drive system, which though is quite common in industries such as surgical robotics. This was one of the first times it's been seen used in FRC. Another new technology, at least for us, is our intakes, because they have to adapt around cubes. We made use of a technology called series elastic that you'll quite commonly see in other more industrial robots such as If you look at the work done by people like Boston Dynamics, the robots that are capable of jumping and landing, those implement series elastic to take the shock out of landings.
Baha, and you mustn't be shy, you were on the Dean's List.
Oh.
What does that mean?
The Dean's List Award, which I was a finalist for, which means I got the award at one of the regional competitions, is an award for like a student that helps further the ideas of FIRST and is a very contributing member to the team. And I was honored to be nominated by my team and win at one of the regionals.
Congratulations to everybody. You did a wonderful job, really.
Thank you.
What was the coolest and most ingenious part of your robot?
Well, again, Sabina said this is quite subjective to each team member. And while the arm I think is really interesting, I think the hidden gem of the robot is the intakes with that technology that James mentioned. There's just so many sensors on that intake. It's my personal favorite part of the robot.
My personal favourite, if we're talking hidden gems, it's about something that was important to me just because it confused everyone else.
Good.
We use pneumatics on the robot, yet typically to run pneumatics you need air tanks, and we simply did not have enough room for those air tanks on our robot. So instead of trying to build in a compressor or having to sacrifice on space, we actually embedded our air tanks in the large part of our arm.
Wow.
Which was certainly a challenge, and I personally loved just for the expression on people's face when they realised what we'd done with them at competitions.
Again, I'm biased, but I think my favorite part of the robot is probably the code and how it works with kind of the drivetrain and the arm and just the feedback that it gives. We're able to control the robot to a point where you can push on it and it'll spring back no matter what you're doing. And for that, I think it's pretty darn cool.
Can someone explain the drive base to me?
So while we make refinements on the central design, our drive base, we build a new one for each robot, but we typically use a similar design. The drive base present here bears remarkable similarity to the one we used in 2015 and 2016. Each year we always find something to improve, but fundamentally it is similar.
Yeah. Well, in other years it's a little different. In 2016 we had to go over a lot of barriers and stuff like that. So we actually had pneumatic wheels. So they were filled with air. So we ran 8 wheels instead. So every year something gets adapted a little differently, just because of the game requires it. But when the game is kind of on a standstill for movement, we normally go with our classic design because it works really well.
Vina, you said you were a coder, right?
Yeah.
Are some of the actions or most of the actions preset or not?
Yeah, so actually in the match, there's 2 minutes and 30 seconds, and the first 15 seconds are autonomous. So a lot of things we had started kind of planning out to be preset just because it's so hard to do something on the fly, especially with a complicated arm that can't go out of its boundaries. So all of the positions for the arm are preset and have individual paths to get back to its neutral position, and how the intakes swing out and in, everything's pre-programmed pretty much.
Who makes the final decision that the robot is ready for competition?
Time. We rarely ever have the robot completely finished by the time the 6 weeks are up. In fact, we typically bag a robot with 75% done, and then we spend the first day of competition frantically bolting the rest of it together. The honest truth about it is the robot's never finished. There's always an improvement we can make, and every competition you'll see a slightly improved version of our robot come out.
If you get to the competition and it doesn't work, what happens then?
So we have a pit crew that works in what's called the pit, which is where the robot lives during the competition when it's not actively competing. And our pit crew works hard to debug any issues we have, fix the robot. We bring a whole set of materials with us that we can use just in case something breaks. Again, it's a partnership between the students and the mentors, so we're all working together to get it running.
Yeah.
Who's in charge of the modifications to the robot during the game, and were there any in 2018?
So there's kind of 2 levels to this. Part of it is the modifications beforehand, where we're planning it and doing the design for it in the computer, manufacturing those parts. And I'd say that's a joint effort between our computer-aided design lead and our pit crew lead. And then when we actually get to the competition, it's the job of the pit crew lead to keep the modifications on schedule and actually be put on the robot.
I know at the competitions you have scouts that go around. They're looking for secrets from other groups, or what? What does a scout do?
A scout, essentially, depending on where you are, is someone who goes around the pits and just looks at the robots and sees what their capabilities are.
First itself, there's a website called Blue Alliance, and they'll give us stats for each alliance during a match. But what our scouts are really interested in is the individual team data. So there'll be 6 people watching each individual robot during every match. And they take data which allows us to form a pick list so we can form a permanent alliance that we compete with in the latter part of the competition.
Why do you need to form an alliance, and how do you choose who is going to be your alliance partner?
We need the alliance because first is fundamentally about the word they use for it is cooperation. Basically, it means that you cannot win one of these games on your own. You have to make use of the people you're playing with. And how we determine the alliance, generally, it varies from year to year, but when it comes down to it, it's a robot's ability to reliably achieve the game objectives. This year we'd look at things like the number of cubes they stacked and how often they're able to climb.
And the way the competition works is the first half you're paired randomly with different team members forming random alliances every single match. And then from that they create a ranking list based on how well you do each time. And then that's when you go and form the permanent alliances during the elimination rounds. And that's how the winners ultimately decided.
You played in San Francisco to qualify, then you played Silicon Valley, and then you went on to the final in Houston.
Yes.
So what was it like in Houston?
For me, since I'm on the drive team, it's a really great experience to see all the other teams and kind of that buzz of people that you've never met before and kind of all the different robot styles, especially teams from not our state and especially not our country as well. They make way different robots that we had never thought of doing or that we didn't pursue, and it's just cool to be a part of something that is so large and there's so many people in it.
Yeah.
How about you, James?
For me, it's the same. It's the fact that it's the buzz of knowing that we took this massive convention centre and packed it to the brim of high schoolers, all of whom are there purely for robots. It's like the people from all over the world got together for the purpose of building robots and having fun, and it's phenomenal to see that.
Yeah, it really is a lot of fun, and I think part of it, like they said, is we all love robots, and then suddenly you're in a giant building with a lot of people that love robots.
How important are your mentors?
Our mentors are, I think, a critical part of our team, and a big message that our team tries to pursue and advance is that it's mentors working with students. And because these mentors are industry professionals, they help the students further their knowledge way beyond what we could do by ourselves. So everything we do on 971 is a partnership between the students and the mentors, and I think we all learn and grow from it.
They fulfill the primary goal of a mentor, which is to guide us. All the skills we use in building these robots, they came from them originally. These are people that they've done first before. A lot of them are alumni. They now work in the industry. So they're responsible for making sure we don't make any massive mistakes. It's their guidance that means that we have such a great robot. They point us in the right direction and prevent us from stepping wrong most of the time.
Do you take the robots out into the community at all?
We do. It's actually a lot of fun. Summertime is our big demo time, and so the Mountain View Chamber of Commerce hosts one event that I think we all really love, the Mountain View Tech Showcase, and we'll actually bring our robot there and demo it for whoever happens to be walking downtown Mountain View, along with a bunch of other community events that we do.
Yeah, it was actually a robot demonstration at my middle school that first got me involved. This was 2014's robot. It was capable of picking up and firing these massive yoga balls, and so they brought it onto our school blacktop and driving it around, launching the balls at the students, and the students had to catch the ball and throw it back to the robot. It's events like this, they're phenomenal to take part in because you get to see the effect you have. And as a student, because I've seen it from both sides, it was also inspirational to watch.
I can see you're all passionate about it.
Yeah.
Baha, what would you say to encourage other students to consider robotics?
I'd say that you don't need any experience to join a robotics team. You just need to be willing to learn and willing to work hard, and that it's a really fulfilling experience, and that everyone should at least try something in STEM out some point in their lives.
How about you, Sabina?
That is summed up so well. I started with, I was in theater and I did choir, and my brother got me into this, and I ended up really liking it even though I knew absolutely nothing. So I think it's just something where you gotta give it a try, because even if you don't necessarily want to work directly with the robot, we have such a family at 971 that it's just worth it just to be in the family.
Well, most teams have a motto, it seems. Do you have one?
We do. I believe our motto is, you have to break a few small appliances to build a robot. It's just kind of a funny thing.
All right.
We're always building.
Well, thank you for being our guests. Well done, and congratulations on everything.
Thank you so much.
And thank you for bringing curiosity here.
Yeah.
And
She was happy to come.
Good luck in the future.
Oh, thank you.
Thank you.
Thank
Yeah.
you.
The team insists that it's not about winning. It really is about playing the game. To see 971 in action at the Silicon Valley game, you may also enjoy watching Robots and Their Young Masters, our other program on this subject, hosted by Jerry Oliver. I'm Val Jeffrey for The Better Part. Thank you for watching, and join us again.